Hey, some countries build new technologies from scratch. Some countries buy them under license. And then there is Israel, a country that learns how to turn a wreck into an advantage. A country that can take a gutted drone and pull out a system for an entire army. A country where reverse engineering is not just a practice, it's a lifestyle. Today I'm taking you somewhere military cameras don't look. To a place where find, strip, understand, rebuild faster is more than a motto. It's the rhythm of work, and I'll tell you a story that really happened. In 1982, in the Bekaa Valley, Israeli commandos captured an entire undamaged radar system. It didn't go to a museum. It didn't go to the scrapyard. It went into a special hangar. A few months later, Israeli drones had learned to trick it so effectively that Syrian operators no longer knew whether they were seeing a real fighter jet or just an echo generated by a system based on their own engineers' work. And that's exactly what today's episode is about. We'll show you how Israel built its navy, its Iron Dome, its export market, its AI systems out of other people's ideas, or rather, out of other people's screws. Let's begin. How did Israel build a navy from leftovers? The sea is an unpredictable element. But for Israel, a state with a coastline and a port in Haifa, it's also a strategic one. And if it's strategic, that means embargoes, restrictions, political obstacles, and lack of equipment. So how do you build naval power when you can't buy it? The answer, as always, reverse engineering. Israel has never been a naval superpower in the classic sense, but it had what big fleets often lacked: determination, cunning, and access to second-hand technology. The story starts with buying used missile boats from France and Germany. But the real game begins when those vessels are modified locally, with their sensors, weapons, and electronics completely rebuilt. The key example? The Sar-class ships. Officially an Israeli design. In reality, an adaptation of the German Jaguar-class fast attack craft from the 1960s, with French radars bolted on, British torpedo launchers added, and Israeli software rewritten on the basis of analyses of intercepted Syrian systems. But the most interesting case? Unmanned kamikaze boats. Small, agile, hard to detect. Controlled from shore or from a drone, Israel built prototypes of such systems as early as the 1990s, studying the solutions used by the Tamil Tigers and converting civilian outboard engines into weapons. How were these boats built? From parts salvaged from smuggled Lebanese craft, fishing wrecks, and even sports equipment. GPS modules were adapted from yacht devices. The camera? Industrial CCTV. The communications module? Copied from Iranian radios. All of it assembled in Israeli shipyards under a veil of secrecy. In 2016, Israel officially unveiled the Protector USV, an unmanned armed patrol vessel. But internal documentation shows that similar systems had been tested much earlier, using captured equipment from Iran and Syria. Reverse engineering worked at sea too. Today, the Israeli Navy is a fleet of upgraded corvettes, missile patrol boats, and unmanned surface vessels. Each one is a technological patchwork: German engines, Swedish radars, Israeli software, mechanics based on analysis of Iranian ships. And as always, the most valuable thing is not what you see. The most valuable thing is what you don't hear. Acoustic camouflage systems, sonar evading algorithms, tricks taken from submarines that disappeared from enemy screens and showed up in Israeli labs. Israel didn't build its navy out of national pride. It built it out of necessity. It built it from scrap. And today, in Middle Eastern waters, you no longer ask who has the biggest ship. You ask who hears the enemy first. And very often the answer is the one who learned to listen to other people's engines. How did Israel build Iron Dome on other people's concepts? Not everything you launch hits. But if you have a technology that can shoot down a rocket with another rocket before it reaches its target, you change the rules of the game. Israel did that with Iron Dome. It sounds like a pure product of national genius, but in reality, it too is a child of reverse engineering. It began with observation. The Gulf War. Patriot missiles, US-made air and missile defense systems, shooting down Scuds. Israeli officers sat in command centers analyzing every intercept and every miss. They collected data, broke down schematics, simulated trajectories. When rockets from Lebanon hit Haifa in 2006, and a few years later rockets from Gaza rained on Sderot and Ashkelon, Israel knew a shield was needed. But not an American one. Those systems were too expensive and not suited for short-range threats. Something else was needed. Rafael, Israel's defense giant, launched the project. At first, drawing inspiration from the American CRAM systems, counter-rocket, artillery, and mortar, but quickly going beyond that. Engineers dissected every piece of existing technologies, radar architectures from Thales, NATO tracking software, control algorithms sourced from Russian technical documentation acquired by Mossad. The result? Iron Dome, a system built around a few key components. M20A4 radar, inspired by solutions from systems like the S-300, but optimized for short range. Tamir interceptors, designed to be cheap, but based on knowledge of trajectories and guidance algorithms from both US and Soviet systems. Software, the true heart of the system, able to predict impact points and decide whether it's even worth shooting. All of that on a budget far smaller than any comparable NATO program. Why? Again, reverse engineering. Israel didn't have to start from zero. It had data, it had components, it had experience, and it had motivation. Real civilian lives under real rockets. Today, Iron Dome boasts over 90% effectiveness. But even more important, other countries don't really know why it works so well. The documentation is closed, the algorithms are locked down. The sources of inspiration are scattered across 3 continents. The US co-funded the project, but Israel was the architect. An architect working off other people's blueprints. Iron Dome is not just a defensive system. It's a manifesto. You don't need to own everything. You just need access to everything and the ability to plug it together before the first rocket lands. How does Israel export other people's ideas? When others create technology, Israel thinks about how to sell it with a profit. Because reverse engineering in Israel doesn't end at analysis. That's just the beginning of a cycle. Copy, improve, patent, sell. And if possible, install it for the client, add service, support, and a healthy dose of dependency. Israel is one of the world's biggest arms exporters per capita, from missile defense to drones, from cyber weapons to battle management software. In many cases, these products carry DNA that did not originate in Tel Aviv, but in Moscow, Washington, Beijing, or Tehran. Example, the Harop and Harpy loitering munitions. Officially, Israeli designs. In practice, based on schematics of Iranian Shahed drones captured by Kurdish forces and passed to Israeli analysts. The kamikaze drones got new electronics, better sensors, modified airframes, but the underlying concept and flight profile remained strikingly similar. Another example, electronic warfare systems sold to India and South America. On paper, fully innovative. In the code, echoes of algorithms from Syrian systems analyzed decades earlier during the Cold War. Often the same quirks, the same transmission vectors. Because reverse engineering doesn't just teach, it also leaves fingerprints. Israel is not afraid to sell to countries that are worlds apart politically or culturally. Azerbaijan and India, Colombia and Germany, Greece and Vietnam. What do they have in common? A need for an edge. And that edge often doesn't come from a clean lab, but from a well-copied enemy system. Again, the legal angle. Israel has not signed a whole set of international agreements regulating the origin of military components. That gives it operational freedom, and with high demand, an economic advantage. Thanks to reverse engineering, Israel can promise rapid deployment, robustness proven in real combat, systems hardened against the same attacks it once tested on its enemies. And that brings us to the key point. Israeli exports are not just about selling weapons. They're about selling advantage built on other people's hardware. We know your system. We know how to break it. We sell a system that can fool it. That's not just a weapon. That's an economic military strategy. And that's why Israeli hardware sells like hot bread. How did Israel build a reverse engineering system? In Israel, reverse engineering is not just a craft, it's a system built end to end, from classrooms to hangars, from school desks to military labs. The state created an entire infrastructure for legal, focused, and strategic copying. It all starts with education. High schools and defense-run technical schools have clearly defined tracks: automation, mechatronics, cybersecurity, material analysis. That's not random. It's targeted selection of future reverse engineers. Young recruits go into elite programs, Talpiot, Atuda, Brakim. They learn not only how to build, but how to de-build. Then they end up in units like Unit 81, Unit 8200, or teams inside Elbit and Raphael. There they learn how to read foreign systems in hardware and in code. Every component, every line, every chip is a source of knowledge. Knowledge that is later converted into patents, products, and export projects. The process repeats. 1. Acquire a specimen from the battlefield, the second-hand market, allies, or auctions. 2. Disassembly and analysis. Every part documented, 3D scanned, tested. 3. Modeling and simulation. Building a digital twin. 4. Reconstruction and modification. Creating the Israeli version. 5. Integration into local, tactical, digital, and doctrinal systems. 6. Export push, demo, field tests, offers to clients in Asia, the Americas, Europe. Israel doesn't hide that a chunk of its tech power rests on adaptive capacity. But it doesn't use the word theft. It says adaptation, replication, reverse innovation. The language is soft. The process is hard and effective. An officer from Unit 81 put it bluntly. In the Army, we learn that anything that ends up in our hands has value. If it works, we copy. If it doesn't, we only copy the parts that did. At military academies, former IDF technicians and foreign systems specialists teach classes. At technical universities, reverse engineering is part of R&D programs. In startups, it's often the starting point for innovation. Everything is tied together by one core. The state stimulates, funds, protects, and uses. Institutionalized reverse engineering is more than a strategy. It's an ecosystem where every kid building a drone from AliExpress parts might one day design a tool that changes the course of a war. And that's why Israel doesn't just copy it. It builds people who can copy better than anyone else. The future of reverse engineering? Once people copied airplanes, then tanks, then lines of code. Today, Israel is pushing into a new layer, copying life itself, consciousness, biology, and neural processes. This is no longer reverse engineering in the classic sense. It's engineering the future, built on AI, bioinformatics, and synthetic models of reality. Israel is pouring billions into AI, but not only to recognize faces at airports. The main game is decoding enemy systems before they act. Future reverse engineering will be simulation-based. Instead of taking a tank apart, you build its digital twin. Instead of intercepting code, you simulate its behavior across billions of scenarios. The heavier punches in bioengineering. Israel is already researching reconstruction of biological structures. For medicine, yes, but also for soldier resilience. They scan physical responses to stress, trauma, noise. Then they build models that predict an adversary's behavior from biological data. AI in Israel already analyzes combat footage in real time and suggests counter-moves. In the future, it will generate its own hypotheses no human could come up with. Every battle will be dissected not only by generals, but by machines that break the opponent's emotions and movements into data sets. And morality? Israel's answer: this is not about morality. It's about survival. If we don't do it, others will. And they'll do it worse. In Israeli tech incubators, startups are already using captured genetic data to design health algorithms, while in the background, building biometric recognition systems that can distinguish a target not by face, but by breathing pattern. In the future, reverse engineering will be invisible. AI will analyze a drone before it lands. Cognitive systems will reconstruct code just by watching how the interface behaves. Biotech will create a copy of a person in the form of a predictive model. It won't be copying things, it'll be copying intentions. And that's where Israeli industry is heading, into a world where reverse engineering becomes a way of preempting the future. Adaptive genius in Israel's DNA? At every Israeli flea market, you'll find something repurposed. An old radio with a new antenna. A Soviet helmet with Hebrew markings. An American backpack turned into a tactical comm set. That's not random. It's a metaphor. Israel is a country that not only learned to copy, it made copying a pillar of its national mindset. From 1948 on, the state was built out of fragments. Immigrants brought tools, books, machines, parts. Kibbutzim made weapons out of tractor hydraulics. Polish Jews assembled rifles using German wartime blueprints. Iraqi Jews brought mechanics who knew tank engines from the colonial era. With no infrastructure, you used whatever you had. That practice quickly turned into culture. Reverse engineering wasn't a crime. It was a civic duty. Any engineering student who could dismantle a device and build something similar was worth more than 10 academics publishing in American journals. In Judaism, there's a concept of tikkun olam, repairing the world. In secular Israel, it became a technological philosophy. If you see a problem, you have a moral duty to fix it. If something works badly, rework it. If something can be done better, do it. That attitude seeped into institutions, the army, startups, and garages. In Tel Aviv, Netanya, or Beersheba, hundreds of companies are born each year on one principle. Let's do what the Americans do, but faster, cheaper, and without asking. Not as plagiarism, as innovation through deconstruction. Company A creates a facial recognition system. In Israel, Company B tests it on Unit 8200's image archives and releases a version that runs faster on weaker hardware. The result? A contract with a border agency in Argentina. They didn't copy the tool, they copied the function. A Pole might say, combinator, a hustler. An Israeli says, combinator, a strategist. In Israeli mentality, kombinowani, hacking together solutions, is not cheating. It's thinking outside the box. If you have 3 parts from 3 different systems, assemble them and see if they work. If they do, you have a prototype. If not, you tweak. Everything might be useful. A drone wreck? Valuable info on its power system. A broken digital camera? A source of lenses for sensors? Old military computers from Bulgaria? Perfect base for attack simulations. This mindset is no accident. It's social firmware. Not written in the Constitution, written into education, culture, the army, the media. How does Israel get the data it needs to copy? There is no reverse engineering without one ingredient: data. And data doesn't fall from the sky. It has to be obtained, captured, bought, forced, copied. In Israel, gathering data for reverse engineering has become its own field, with its own logistics, budget, and doctrine. It's not about random war trophies. It's a systematic intel industrial program. Source 1. War. The most obvious, captured weapons. After wars with Syria and Egypt, equipment went to Israeli technical units. Every component was dismantled, documented, analyzed. Replicas were often built from scratch. In 1982, Israel captured an advanced P-18 radar. It was taken apart piece by piece. A few years later, elements of its design appeared in Israeli ECM systems. Source 2. Secret purchases and auctions. All it takes is an auction of surplus military gear in Europe or Asia. Officially, private companies are bidding. In reality, fronts for Israel's defense sector. Example: the purchase of Russian systems from former East Germany via a Swiss company that conveniently vanished soon after. Source 3. Industrial deals with developing countries in exchange for training and technical assistance, access to their weapon stockpiles. Soviet-era gear from the 70s, Chinese clones of American systems, optoelectronics from Pakistan, components from Indonesia. Everything cataloged, scanned, mapped. Source 4, Mossad. Theft of Mirage documentation. Grabbing S-300 data. Operations against Iranian systems. Modern Mossad is also cyber. Supply chain attacks. Breaking into industrial servers. Infiltrating companies via fake contracts and tenders. Source 5. Darknet and hacker forums. Monitored around the clock by special teams. New firmware file. New leaked source code. Straight into the queue. Example. A leaked codebase of a Chinese anti-drone system appears online. Within 72 hours, it's sitting in a lab in Haifa. Source 6. Fragments. You don't always get the whole drone. Sometimes just a PCB board or a heatsink. In Tel Aviv, there's a unit nicknamed Digital Bone Reconstruction. They assemble a working model from whatever pieces they have. Reverse engineering from fragments. Engineers read production dates from solder layers, determine metal origin, map screw imprints. Source 7. Manuals, leaflets, patents, yes, even leaflets. A user manual for a Russian radar system obtained in Iraq helped predict its reaction to jamming. An old Chinese patent was used to build the cooling system in the Harpy drone. Source 8. System-level analysis. Watching how an enemy system behaves. Does it delay reaction when a drone approaches? Does it change frequency? Does it reboot? All of that is data. Data that feed Israeli algorithms. When Iran shot down a U.S. drone, Israel studied how the comm systems reacted. From that analysis, they created a rulebook for electronic warfare. Source 9. Cooperation with foreign companies. Joint projects, officially about satellite comms, often serve as a smokescreen for getting design data. As part of one European partnership, Israel gained access to an inertial guidance system used in surface-to-surface missiles. Source 10. AI and automation. Today, part of this collection process is automated. AI scans the internet, registries, code bases, open-source intelligence. New code repository? It's being analyzed. New schematic in a PDF? AI tries to turn it into CAD. Israel doesn't just analyze. It builds infrastructure to harvest data. Data is the new raw material. And this raw material is processed faster than anywhere else, because there's no need for endless procedures, approvals, certifications. All you need is a team, a laptop, and the skill to read someone else's system. This isn't just reverse engineering. It's technological intelligence at industrial scale. It's a data-driven economy. And it's data, not steel, not missiles, not aircraft, that is Israel's greatest source of power. Imagine a lab that looks like a junkyard, a crate of Russian chips, a box that once held French missiles, a Chinese CCTV camera next to an American flight controller. In the corner, a gutted drone that was flying over Syria last week, and now already speaks Hebrew. This isn't a cyberpunk fantasy. This is Israel, a country that doesn't need to buy licenses, because it buys wrecks, and from wrecks, it builds power. While other countries race for labs, grants, and PR, Israel is playing a completely different game. The game of find, strip, understand, rebuild faster. The game of survival. Because here, in the Middle East, if you don't improvise, you die. So instead of protocols, there's a soldering iron. Instead of an export license, a teardown team. Instead of debates about NATO compliance, results on the battlefield. This is not a country of plagiarists. It's a country of data surgeons, recycling engineers, agents of logic, dealers in advantage, technical guerrillas. And that's why, when you ask, how is it possible that such a small country dominates technology so effectively? The answer is, because it doesn't ask for permission. It asks for a screwdriver. If you want more stories like this, hit like, hit subscribe. That's the signal that this series is worth continuing.